Okay, welcome back. We're going to look at two more examples of dividing rational expressions. You can also consider these really examples of multiplying rational expressions as well, because remember, we take each division problem and turn it into a multiplication problem. So our problem here is v squared minus 3v minus 18 over v squared minus 6v plus 9 divided by v minus 6 over v minus 3. So again, first thing you want to do is rewrite it as a multiplication problem. So the first fraction stays the same. The second fraction, the v minus 6 over v minus 3, they get flipped. And so we have then now v minus 3 over v minus 6. At this point, I would encourage you to pause the video. You have some factoring to do. And go ahead and do that factoring. So to begin with, we have the fraction v squared, the numerator, v squared minus 3v minus 18. So we need things that multiply to be negative 18, that add to be negative 3. Things that multiply to be negative 18, that sorry. Let me say that again. Things that multiply to be negative 18, that add to be negative 3. Okay? So the two numbers we want will be a positive 3 and a negative 6. And then we move to the bottom. We have v squared minus 6v plus 9. We need things that multiply to be 9 and add to be negative 6. That would be a negative 3 and a negative 3. The other fractions there, v minus 3 and v minus 6, those other pieces of that other fraction, nothing we can do as far as factoring. So now we've done the factoring part, and now we get to do the fun part. We say, hey, I have a v minus 6 in the top, and I have a v minus 6 in the bottom. So I cancel out the v minus 6's, look for anything else. I have a v minus 3 in the bottom and a v minus 3 in the top. Now I still have v minus 3 in the bottom, but there's nothing else I can do there. Right? I can't cancel it out because there's nothing left in the top. At this point, we put everything together. Now I have v plus 3 over v minus 3. Those are not the same, and if you checked, they're also not opposites. If you took a negative sign out of the bottom, you'd have negative v plus 3, which is not the same as v plus 3. And so they're not opposites. We cannot cancel the 3's, we cannot cancel the v's, because those things are being added. They're not factors. Okay? And so there's our result. Now, our last example is, well, a real doozy. 27n squared minus 12 over 3n squared minus 5n plus 2 divided by 9n squared plus 3n minus 2 over n squared minus 6n plus 5. Okay. It's a division problem, so first thing, let's go ahead and rewrite it as a multiplication problem. Now what makes this problem here particularly grueling is that unlike the examples we did previously where our factoring was fairly straightforward, here we actually have several multiple step factoring problems that we have to do. When you run into a problem where it takes a little bit of extra work to do a particular step, then you may want to break it down and just focus on each of the little steps that you have. So that's what I'm going to do here. So I'm going to take each of the 4 pieces of my fractions and work on factoring those individually. So 27n squared minus 12, this one might throw you off. It's a 2-term polynomial, but it's not a difference of squares. At least not in the form that it's currently written in. So the only thing we can really rely on is, let's take out a common factor. So we take out a 3. Now, taking that 3 out actually does allow us to see that there is a difference of squares lying underneath. 9n squared minus 4. So we go ahead and factor that. Things that multiply to be 9n squared would be 3n and 3n. Things that multiply to be 4 would be a 2 and a negative 2. So it factors as 3, and then 3n plus 2 and 3n minus 2. So I'm just going to draw a little box around that so I don't forget about it later. And then I move on to that denominator. the denominator, 3n squared minus 5n plus 2, we're stuck with something in front of the square term. We say, oh gee, great. So remember, to do that now, we have to find things that multiply to be 6, that add to be negative 5. When we do our search for our numbers, and now I would ask that you would pause this video. It may have been a little bit of time since you've done one of these, and try to work that out. Okay, now remember, coming back now, that when we find the numbers that multiply to be 6 and add to be negative 5, that we're going to replace the middle number with those two numbers. So either as a minus 2n minus 3n, or as I've written it, with the minus 3n first. And now once we've written it as a 4-term polynomial, we do our factoring by grouping, pulling out the common factor for each. So again, if you had trouble with the first part, pause it and try to do the grouping. So in the first part we can pull out a 3n, we're left with an n minus 1. In the second part we can pull out a minus 2 and we're left with an n minus 1. Okay? And so then we can pull out the n minus 1. Whoops, video's getting ahead of itself. We can pull out the n minus 1 and we're left with a 3n minus 2. And so now we have our second fraction. And that brings us to our third piece, which is our numerator of the second fraction. And that's actually, of the factoring problems, the one that is by far the easiest one to do. Alright, n squared minus 6n plus 5. We're looking for things that multiply to be 5, add to be negative 6. And when we do that, we find that we need a minus 1 and a minus 5. And so the factor is n minus 1 and n minus 5. Okay, and we have one last denominator, 9n squared plus 3n minus 2. And so now we focus on that. So again, because we have something in front of the squared term, we need things that multiply to be negative 18. 9 times negative 2, and add to be 3n. Again, I would encourage you to take some time, try to factor that yourself. So the two numbers we need are 6 and negative 3. So again, we replace the middle term, the 3n, with 6n minus 3n, and then we do our factoring by grouping. So 3n and then 3n plus 2 will be left over. Second part, 3n and minus 2, we can pull a minus 1 out. We have 3n plus 2. So we're left with 3n plus 2, we pull out, and we're left with 3n minus 1. So it factors as 3n plus 2 times 3n minus 1. So now we've done all the factoring. Whew, a lot of work. A lot of work. Although you may have some of this type of factoring in problems that you'll do on your test when it comes to your exam, I almost certainly wouldn't put a problem where you would have this much in just one problem. It can be overwhelming and very time consuming. Now that we've done all the factoring work, the whole point of that was to simplify the problem. So we put it back together. So I take my first numerator, write it down, my first denominator in its factored form, and write it down. My second numerator, n minus 1, n minus 5, write that down. And then my final denominator, 3n plus 2 and 3n minus 1, and I write that down as well. Okay, now for the reward. May not seem like much of a reward after all that work, but now we get to cancel stuff out. So I see a 3n plus 2 in the top, and I see 1 in the bottom, so I cancel them out. I see a 3n minus 2 in the top and a 3n minus 2 in the bottom, so I cancel them out. I see an n minus 1 on the top and an n minus 1 on the bottom, and there ends my canceling spree. So at this point I take what's left. In the top, 3 and n minus 5, and in the bottom, 3n minus 1. And now finally, I am done. Okay, so these can get involved with the factoring you have to do. When that's the case, I do suggest breaking it down and working on each piece individually. And again, as far as an exam, I would not have a single problem nearly as involved as this one here is. Again, you may have some of that factoring that's been in this problem spread throughout other problems, but nothing that would be quite this involved. But it is a good example. It's a good review of all the factoring we've done. We've actually, in doing this problem, basically done an example of just about every type of factoring we've talked about, all in one problem. So, good luck.